Hi dear students, so this is Riyaz sir. So we have a very good question in front of you. We will try to understand that. So let us go through the question. The question given here is Preeti reached the metro station and found that the escalator was not working. Okay. She walked up the stationary escalator in time t1. Okay. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. Calculate the time taken by her to walk up on the moving escalator. So, this is a question which actually talks about three individual cases. Okay, so what is the case one? The case one is that the escalator was not working. Okay, so we will divide this into the three cases and try to understand and do it. Okay, so we will put like case one. Okay, so we'll make it little more big. Okay, so we have the case one out here. Okay, so in case one we say that escalator was not working. Okay, so who will be moving? I can say escalator would be escalator is here stationary, so it is not moving. Okay, it is stationary. Okay, now what about Preeti? So we can talk about Preeti. We know that Preeti, she is moving actually. Okay, so she is moving, so I can put it like that. Preeti is moving. Okay, if she is moving, surely she will have some velocity. So let us assume her velocity in this case is v1. Okay, I hope until this it is clear. Since it is stationary, here the velocity would be how much? It would be 0. Okay, no doubt in that. Now we have the case 2. We are coming to the case 2. Okay, so in case 2, what is happening? Students, see, in case 2, we will think about. So in case 2, they are talking about what actually? So on other days, I can read the question. On other days, if she remains stationary, that means she is staying on that escalator, the escalator is moving up, then the escalator takes up a time of t2. So let's say in the case 2, we can write it like this: escalator is moving. Okay, escalator is moving. Okay, so we know that if it is moving, it will have some velocity. So let us assume that velocity as v2. Okay, and she is remaining stationary, so I can say here Preeti is stationary in the second case. Okay, so Preeti is here stationary, so Preeti is not moving. Stationary means she is not moving, so in that case her velocity should be 0. Now in the first case, the escalator, when it is stationary and Preeti was moving, so it was taking a time of t1. It is mentioned in the question, it is taking a t1. And in the second case, when the escalator was moving, it takes up a time of t2. So we need to mention that also here. So let us write here. So it is taking a time, velocity is v1 and it is taking a time of t1 here. And here v2, we know that when escalator is moving along, it is taking a time t2. Okay, until this we know. Now what we need to find out? So in the question they are taking the time taken by her to walk up on the moving escalator. So what is the case 3? Case 3 is the case where both of them are moving. So let us say case 3. Case 3. So in case 3, I can say both escalator and Preeti is moving. Both of them is moving. So they will be moving, then both of them are moving means there will be, I can say, we will consider that together the velocity as capital V. Now the question is, what is this capital V would be? That is the crux of this question. So let us think about what is happening here actually. Okay, I will add one page. Okay, I'll add one extra page here. So let us say here, let us try to understand. So let me say here, let the escalator moves like this. Okay, she is moving and the escalator is also moving. Okay, so the escalator is moving. Okay, let me write. We know its velocity. When escalator alone moves, we know that its velocity would be v2, and Preeti moves, its velocity is v1. So let's say it is v2. Okay, now here Preeti is there. Okay, let me draw Preeti, but I'm not good at it, you know. Okay, so Preeti is also moving. Now when Preeti is also moving, she might also have a velocity. We already noted that her individual velocity would be v1. Now you can itself think like when you are in a supermarket and when escalator is there, you are moving and you are also walking, and both Preeti and escalator is moving. So we know that in that case the effective time to reach the top to reach the top increases or decreases. We know that it will decrease. Why? Because since both are moving, we can say that she will reach very fast at the top. Correct? So it will be very fast for her because she is also walking here, and the lift and the escalator is also moving up in the same direction very fast. So that I can say that the effective time decreases, and let me say that effective time would be T effective. Let us assume. Okay, T effective. Okay, so we need to calculate this time only in this question. Okay, now let us formulate the formulas for each cases. So in the first case, we know there is no acceleration in this motion. So let me say in this case, what would be the normal equation we would use? Think about that. We know that distance is equal to speed into time. So let me say the distance we need to move here is d. Okay, so speed is v1 and it is taking a time t1. Correct? So similarly in the second case, what would be the case? So distance would be the same d, it is not changing, but the speed is v2 and it is taking a time v2. So these are the two equations in the first and second cases. So let me highlight that for your understanding. Okay, so here also I am highlighting it. Okay, so you can see here. Okay, now let's go to the third case. So in the third case, let me say here, how will you put the formula? Okay, so let me say the formula would be again the same. The distance would be the same d. Okay, it is not going to change. Speed would be, we know that the effective speed v. Okay, and the time would be t effective. Correct? I will put it like t effective. Correct. I hope you understood. Now we need to find out what actually the t effective, we need to find it out. Okay, now before that I should arrive at what is this effective velocity v. Let us say the effective velocity, the new effective velocity with when both of them are moving would be, she is moving v1 and this escalator has a velocity v2. It would be v1 plus v2. Why? Because if the velocity increases, then only the time will decrease because they will reach very fast. That is the logic I am using. Okay, so the velocity should increase, then the effective time should decrease. Okay, I hope it is clear. So now let's substitute this. Okay, so we can say d is equal to, we have v1 plus v2 into t effective. Okay, now let's calculate what is t effective here. Okay, so I would say t effective would be, I can say rewrite this equation as d by, okay, v1 plus v2. Now what is v1 from the equation? Already we know what is v1 would be. So from here I can write v1 would be equal to d divided by t1, and here v2 would be what actually, what would be v2 would be d divided by t2. Any doubt? I hope it is clear. Very straightforward. Okay, now let us substitute here effectively. So let me say d divided by v1. Instead of v1, I will put it here, this one, what we found it out, d by t1. Okay, so d by t1 I will put it out. Okay, and similarly v2 I will keep it out as d by t2. Now let's do the calculation. So I will take d at the numerator is already present, and I will take d common in the denominator. So it will automatically become 1 by t1 plus 1 by t2. Okay, so we can cancel this one. So I can say t effective would be equal to 1 divided by 1 by t1 plus 1 by t2. So please calculate this. So on calculation, what you will get, sir? Let's think about that. So this will become 1 divided by, so if you cross multiply it, this will become t2 plus t1 divided by t1 t2. Okay, now I can rearrange it, and finally I will get the effective time in third case would be t1 t2 divided by t1 plus t2. Okay, so this would be the effective time when both of them would be moving. Okay, so the important concept here, most of them should remember here, is when both of them are moving here, the effective velocity increases. Okay, this is the checkpoint, and because of that, when velocity increases, she will reach the top very fast. So the effective time would decrease. Okay, I hope it is clear for you. Let us check for the answer in the options. Okay, so let's check here. So we have the effective time here, that is option 2 would be the correct answer. Okay, so for more questions, please subscribe the channel. Okay, you would be continuously getting questions to crack your NEET exam. Please subscribe the channel. Thank you.